So we have a problem statement as the truss. So we have A, B, and C, and this is a truss. And there is a load at B, which is 500 newtons, and the length of A to C is 2 meters, and then A to B is 2 meters. The question is that, so we have a pin at A, and then rocker at C. The question is the members are the members AB, BC, and AC in tension or compression. Okay, so that's what we need to find. So for example, the member AB, is it in tension or compression? Member BC is in tension or compression. Similarly, member AC. So I will use the method of joints. So you will see that we have two methods, and one of them is the method of joints. And then before we start to apply the method of joints, so what we will do is that we will write, the step one is that, so we have to write the equilibrium equations for the whole truss. Okay. And to write that one, I will write the reaction forces at A, and then I know that A is a pin, and then pin has a reaction force of AY, and then AX. Similarly, the rocker at C will have a reaction force of CY only, because it is free to move in X direction. Okay, and then so we have the normal force or reaction force at here, which is CY, and then we have the AX and then AY, and then we have 500 newtons. Okay, so we will say that the forces acting in X direction are 0, and then we will take to the right as positive. We have the AX, and we have the 500 newtons, and that's equal to 0. From here, AX is negative 500 newtons. And similarly, we will write the forces in Y direction, and we will take up as positive, so forces in Y direction is equal to 0, so we have the AY, and we have the CY, which is equal to 0. Okay, and then so you see that we have two unknowns, but we have one equation, so it means we need one more equation, so that the final equation will come about the moment equations. So we will say that the moments about any point, you can take any point to be 0, but for this one I will take point A, because this one has more unknowns, so this way I will eliminate the point A unknowns. So I will say that the A is equal to 0. Okay, and then okay, so if I do that, and I can see that about point A, this one creates a counterclockwise moment, and this one creates a clockwise moment, and this 500 has an arm of 2 meters, and this CY has an arm of 2 meters. So I will say that the CY times 2 meters, which is a counterclockwise moment, so we'll put this way, and that's it is positive, and this one has a clockwise moment, so it will be that minus 500 times 2 is equal to 0. Okay, and then we have the CY value. From here it will follow that CY will be 500 newtons. And since I know the CY, if I go back to the equation here, And from here I can get the value for AY, which will be at negative 500 newtons. So it means that the direction at AY here, it should be the opposite, downwards. Okay, so it should be down, so the direction I chose was wrong. And so that we have AX, we have AY, and then we have the CY value. And then the time is to now to use the method of joints and to find the unknowns at joint A, joint B, and then joint C. Okay, so let's do that. So we have found that AY is negative 500 newtons. So since it is negative 500 newtons, I will just put this one as this way. AX, we have found that it is also negative 500 newtons. So since it is negative, so we'll do to the left. And then CY was 500 newtons, and this is correct. Okay. So now we can move to the method of joints. So we will have step 2. Okay. In step 2, we will write the equilibrium equations for each joint. So firstly, joint A. Okay. If I write the joint A here, it has a force of AY, which is 500 newtons. Okay. So now I can correct the direction here because I will correct this sign because I had the direction as right, so it will be positive. So this one also I corrected, so it will be positive again. So we just put the positive value. And there is an AX value which is 500. Okay. And there is a force on A by the member AC. So this one either pulls it or pushes it. But since I don't know which one is true, I will just assume that it is a pulling force or a tensile force. So I will just say that there is a force acting on joint A by the member AC. But I don't know the direction, just assume it. Similarly, the AB, again I will assume it. Okay. And then we have two unknowns. It means we need two equations. So the equation number 1 will be that the forces in x direction is equal to 0. So we have one force and two force. This one is negative since it is to the left. This one is positive. So it will be that negative 500 plus FAC, and then we will have the FAC as 500 newtons. Okay. That is for the x direction forces. Similarly, we will have the y direction forces. Okay. And this one will have the negative 500 again, and then positive FAB. Okay. And then we will have the FAB as 500 newtons. Okay. So means that this one is positive, this one is positive. So we are sure that there is a tensile force, pulling force acting on A, and there is a pulling force acting on A again in this direction. So step 2, joint A is okay. So now we will move to joint B. Okay, so we will have the joint B. Okay. And for a joint B, and so we have found that this force for A is in that direction, okay, pulls. So by Newton's third law, the force at B should be equal and opposite, okay? So if this is that way, the other one should be this way, okay? There should be equal and opposite force on member AB so that the AB member is in equilibrium. Otherwise, it can break. So if you have two forces in the same direction, it can break the member or it can deform it. So for our case, since the overall member is in equilibrium, so we don't assume that way. So we will say that the force acting from A to B is this way. Therefore, the force from B to A should be that way, equal and opposite, so that the member AB is in equilibrium. So I will have a force from B to A, which is AB. Okay, so I will add it here. FAB by Newton's third law is equal to FAB found for joint A. Okay, but this one is equal and opposite. And then we have the force, which is 500 newtons acting that way. So we'll just put this one as here, 500 newtons. And then finally, we have a force acting on joint B from B to C. I don't know it is pull or push. Again, I will assume that this one is a pulling force. So FBC. Okay. And I know that the angle is 45 and this one is 90 and that's 45. So I will just put this one as 45. So we will have the equilibrium equations as well, but we have to first check how many unknowns do we have. So we have one unknown, and this one is known because we know that it is 500 newtons, and that one is, so that value is known. So we have one unknown, so it means that one equation is enough. So either this one or that one is enough to solve the problem. I will say that, so as I said, there is one unknown, so you can put either f of x is equal to 0 or f of y. Okay, both of them will give the same answer. So we'll just go with this one, f of x is equal to 0. So FBC has two components, one is in this way, one is in that way, so that since the angle is 45, it doesn't matter you put cosine or sine, but for consistency, the x component will be sine. So I will just say as 500 newtons, okay, and since this one is also positive, plus the FBC sine 45 is equal to 0. Okay, and sine 45 is 0.70. So from here it follows that FBC will be equal to negative 707 newtons. Okay. And it means that the direction that we have for B is wrong, so it should be this way. Okay, that's for the joint B. Okay, so we have all unknowns found for joint B, we have all unknowns found for joint A, and then the final one will be joint C, and then we will find whether these members are in tension or compression. For joint C, we have Cy. Okay, we have the force in member AC, and we have found that the force in member AC for A is 500 newtons. And if you remember, we assumed this one to the right as a tensile force. Okay? So it means that by Newton's third law, the force at C will be to the left. Since this one is to the right, there should be equal and opposite to the left so that the member is in equilibrium. So I will have a force this way, which is FAC. Okay? And again, Newton's third law, it will be equal and the opposite. And the last one will be force member BC. Okay? And then we have found that that force is negative 0.707 newtons. Negative means that we said that the force is this way, but it came out that the force is that way. Okay. So if I just look for member BC, we have found that the force is negative 707 newtons. And then we were assuming that the force is that way. But the result says that it is negative, so I will just add the correction here. This will be, I will add a positive sign here, since I added the correct direction. Okay. Since it is positive this way, again, by Newton's third law, okay, there should be a force equal and the opposite. Okay, so that force will be this one. Okay, that will be the FBC. Okay, and we know FAC, which is 500 newtons, and the FBC is 707 newtons. Okay. So we don't have any unknown for C. Okay. All the values are known for C. That's the reason that we don't need to write any equation. You can just check it. You can write one equation and check that the values that you have are correct or not. So let me do one. For example, I will just, so this one is check. So I will say that the forces in x direction are 0. And I have a force which is negative FAC. And this force, negative FAC, will be negative 500. Okay. And there is FBC and its cosine component. Okay, this way. So plus FBC is 707. And then cosine 45. And then from here, so we see that 500 is equal to 500. Okay. It is true. So it means that the values that we have are true by checking. So this one is just for check, okay? And now the time is to determine whether each member is in tension or compression. Okay, so let's do that.